Thank you for invitation. First of all, excuse my voice. So I may cough a little bit. I wake up sick this morning. Uh, my talk will be about today monitoring real-world light exposure and its impact on sleep. I am Altug from Izmir Institute of Technology, Turkey. I am an assistant professor here. And today I will present data from my postdoc years from the United Kingdom. And then also we collect data from Turkey as well. So this data covers nearly 5-6 years from Manchester to Turkey. I will cover today measuring light exposure in real world, and that will include part from wearable light monitors, but also how we can collect light exposure using questionnaires, and also some preliminary data, which is a novel method for me, how we can collect light exposure using interviews. And then in the second part, I will show some correlations between these measured real-world light exposure and then sleep. Starting with a brief introduction, we should get a bright and early daytime light and no light at all at night. Unfortunately, we are living in a constant light exposure with screens, city lights, and because of our study or occupational settings, insufficient sunlight, such as night shift works, sometimes inappropriate light exposure at night. So overall, it impacts our health. And how? First of all, light exposure synchronize our biological clock. And then through biological clock or independently through light exposure, it affects our sleep. And evening and night light exposure is associated with delayed circadian phase, melatonin suppression, increased alertness in evening time. And in terms of sleep characteristics, it took longer to fall asleep, reduction in sleep efficiency, reduction in deep sleep and sleep architecture, and increased sleep fragmentation. And in contrast, if we get early, bright morning light, it will advance our circadian phase, increase alertness during daytime, better subsequent sleep quality, and increase deep sleep. And overall, if we get inappropriate light exposure, it will disrupt our psychological and physical health. So that is important. And the next question is actually, what is light exposure before we start measuring that? If we understand which contents it has, then we may able to provide the best method to measure it. And the first point is intensity. We should measure intensity accurately. The higher the dose, produce stronger the response. And the second point was the timing. For human, later exposure means delay, and early exposure means advance. So we should definitely measure the timing information. Then the exposure duration, that is critical as well. The longer exposure duration give the greater response. And the same with the stability. In a longer term, consistent light-dark pattern promotes more robust response. And the final one is spectrum. Each photoreceptor we have different sensitivities, and each of those may act on different mechanisms. So we should be able to measure light according to that photoreceptor system. So returning to our light monitoring, which technologies are available now? The first option is satellites. So this technology is evolving, and for many years, that's a good option to monitor light pollution, especially. And it has been used in large epidemiological studies widely. Unfortunately, that is not capturing personal light exposure. The special resolution is not good enough. It can be combined with novel methods such as smartphone, for example. So this is a recent study from Germany, and they have an app, and people sometimes report their street lights, sometimes take image of that, and combined with the satellite image, it nicely clustered the type of street lights and the number of street lights. So that is a good example of citizen work, and it correlate some type of street lights and it is exposure. This is my study. We also use smartphones, and we relied on actually the light sensor on smartphones. Whenever they use the app, it measures lux values in the environment of that users. That's a good. We may able to collect different times of day, the light exposure pattern, personal light exposure pattern, but the limitation is that it was not continuous. It's not measuring what we want to measure, and it is not measuring the spectrum as well, and it is just cross-sectional observations. Obviously, if we have any sensors, any photometers or spectroradiometers, we may able to collect environmental observation at snapshot of that illumination. But returning to the first question, this is not what we aim. So I think the answer is variable light monitors, because intensity, it is a yes. With a developing technology, high dynamic range, we may able to measure intensity very well. The timing, if we continuously monitor, that will give us a timing information as well. Duration, that is related to frequency. If we are sampling enough, then we can estimate the exposure duration. If we have a multi-day measurement, then we can calculate stability as well. The spectrum, it is a question mark, because all the sensors were lux sensor. They measure photopic light exposure. And now we know the sleep, circadian rhythm, and all other non-visual effects of lights are regulated by melanopsin, which is sensitive to short wavelength blue light. So we actually need to measure melanopic excitation. So now 5-6 years ago, of course, variable light dosimeters were in the literature. Mostly the lux monitors have been used in that time. And we decided to develop our own variable light monitors, which may able to monitor melanopic lux instead of lux. So how we achieve this? Because there is no single sensor that fit with the melanopic sensitivity. So instead of one sensor, we sample the light in 10 different wavelengths, then combine these 10 channels and try to estimate melanopic irradiance. And it was actually quite accurate, and we were not the only group doing that time. It was very timely, and now even in the market, these devices are available. But that was a good start for us, because we were at that time able to monitor melanopic lux continuously for 1 week, and that gives us that kind of information from one participant. So that is a 1 week of a participant and melanopic lux. Look at the 6th day, and we can see that on the 6th day, that individual gets very intense and unfragmented, long duration, bright daytime light. And on the previous day, 5th day, that participant exposed to very long, unfortunate evening and nighttime light exposure. So having that data enable us to calculate all the light metrics we want to calculate. And again, that time, a consensus recommendation is published. First of all, they said, if you want to give lighting recommendation for sleep and circadian science, they should measure melanopic lux instead of lux. And they check the circadian phase, melatonin suppression, and subjective alertness dose responses for melanopic lux. And they gave recommendation that in daytime, we should be exposed to more than 250 melanopic lux. 3 hours before our bedtime, it should be less than 10 melanopic lux, and during sleep, it should be dark. And then I decide, okay, I have the device able to collect the personal light exposure. And then there is a recommendation. So I start collecting personal light exposure in United Kingdom, Manchester, and ask the first question that, do people meet that recommended healthy lighting levels? And currently now I have 150 participants and hundreds of weeks of light monitoring. And unfortunately, more than 75 of the people never met that recommendation. They have insufficient daytime light and more pre-bedtime and more during sleep time light exposure. And then that was obvious that there is a public health crisis of inappropriate light exposure. I always monitor throughout this presentation in my work light measurement using wristband. And one obvious critics was that, is it really measuring personal light exposure, ocular light exposure? Because we should measure ocular light exposure. And the wristband may not be accurate. That's a very good question, actually. Sorry. And in this study, I collect data from forehead, chest, and wrist simultaneously in different lighting levels, different light types, different activities, different body position, and all types of wrist positions, and all the combinations. So overall, mean melanopic lux was similar in forehead and chest, which is very good. And it is slightly underestimated by wristband. And when we check the reason for that, it is mostly because of the occlusion or facing down or the wristband. The body position or lighting type did not change significantly, that underestimation. So that was promising. I believe that the wrist is still the best option, easiest option to collect large-scale personal data in real world. But that was just the intensity of light exposure, because it is just a snapshot of measurement, not continuous measurement. Recently in Turkey, from 17 participants, 120 days, I collect forehead, chest, and wristband simultaneously. And it is just continuous measurement for that participant. Now I am able to calculate all the light exposure metrics related to intensity, timing, duration, stability. And this is a preliminary data. Of course, we need more data, but it is very promising, because in the intensity, I have observed the same pattern. The wristband is underestimating, and forehead and chest are similar. But luckily, in all other light metrics, it doesn't matter. Chest, head, and wrist, they are same. So actually, that was good for me. And why this is important? Because in that data of 17 people in Turkey, people mostly report negative experiences, and all these negative experiences led them to remove the device. They report it is a constant pressure of explaining themselves to other people. It is not uncomfortable. So that means that we want to collect accurate light exposure data. If we want to go with the forehead, glass relying on eyeglasses, it will cause non-wear time, and actually we will collect less data, inaccurate data. Of course, that will change if the sensor technology is changed, if they minimize the sensors, but that will unfortunately still rely on, oh, sorry for that. That will unfortunately still will rely on the eyeglasses, which is very uncomfortable for the people not familiar to that one. So we are good at collecting objective light exposure, and understanding fully that behavior is important, because then we can guide people and use the lighting as a therapy. So this is a bunch of examples, and we can use to depression, insomnia, in sorry for the noise.
Altug, we actually don't hear the noise. So
Oh,
I think
okay. Sorry.
your microphone is very good.
Okay, it's a construction in my building, sorry. uh, so in occupational settings, in schools, so in any place, we can use the lighting information, but we need to understand that objective behavior fully. So what is light exposure behavior? In that framework, it actually includes our geolocation, our climate, temperature, photoperiod availability, then our culture that will shape by personal preferences, my architectural design, my city design, my personal choice. We need to understand all of them so that I understand the reason of that behavior. But just measuring objectively is not giving me that information. So I changed my perspective then, not quantitatively measuring this, but just let's do interviews to people and qualitatively ask that light exposure behavior. So this is from Turkey. We are doing 30 minutes interview with the people, and now we reached the sample size 40. It is still ongoing effort. And we ask, what is your typical light exposure pattern? When, where, what type of light have you seen? Why did you prefer that behavior? If I guide you, if I want to change that behavior, was it easy to you? Do you willing to change this? And also, uh, does this light has effect on you, on your health, cognition, well-being? So that was actually a very good approach for now, because I am now able to map all the daily light exposure pattern of participants and type of lights, the reason to that behavior. Now we'll show you some themes that I capture up to now from Turkey. For example, nighttime light using. This is very strange, but people frequently prefer to keep their light on during sleep. And they mention the security issues or fear of dark. And blind use, privacy, that is very cultural. And people heavily use their blinds. Seasonal sunlight avoidance, that is another themes we capture. In summer, because of heat and brightness, that shape their personal light exposure. Socioeconomic factors, that is critical, because in the guidance, let's say, if there is a healthy lighting options available, if it is expensive, they said they will not use it. And in terms of awareness, they are somehow aware of effects of lights, but they mostly aware of daylight effects, and they mention mostly alertness, vitamin D, and skin cancer. So that gives us a good information for guiding people. Other options to monitor light exposure in everyday life can be questionnaires as well. So that is a very good method, because measuring with wearable monitors 1 week from each participant, it is costly and not easy for a participant, for experimenter, if we want to aim large thousands of epidemiological data. So if we are able to collect the same information with questionnaire, then that's great. Let's do just surveys and collect thousands of information. So now we have light exposure behavior assessment, LEBA. It measures light exposure in 5 different factors: wearing blue light filters, spending time outdoors, using phone, smartwatch in bed, controlling light environment before bedtime, and using light in morning and daytime, during daytime. So one study used that questionnaires and collect objective light exposure as well. So in Switzerland and Malaysia. So that was interesting because it correlates the subjective and objective light exposure in one country and did not correlate in that extent in the other country. So that gave me a hint that that light exposure behavior, or either maybe effect of language and their subjective perception to their personal light exposure behavior, is heavily cultural. So in the next study, I decided to translate that questionnaire and collect validity data from Turkey. So I use trapped method. So independent translator, reviewer translated that in an iterative state. Then we do interviews, ask participants, target population, if they are able to understand that questions, then culturally adapt the question, then that gave the final shape to translated questionnaires. Then after we have the questions, I go to the 10 experts and ask in Turkey, is this content valid in this context? And the validity index was very high. That means we have translated very well and the content is good in this target population. Then we start to collect online data in Turkey, but also Turkish expatriates in abroad as well throughout the world. Our just inclusion criteria, the Turkish should be the mother language, main language, and the primary language. Nowadays. And in total, we collect 445 participants. The first analysis was confirmatory factor analysis. So I want to check if the same 5 factors is valid in our target population with a translated survey as well. So in the first model, I replicate the original articles specification with the same covariance, same coding, same equality constraints, everything. So the model was nearly perfect. There was some small rooms to improvement. Then I performed the second model, removed the item 9 and 10, then it was a near perfect fit. So that was a good, that means that these 5 factors, we may able to use that language. Translated questionnaires can be used in Turkey as well. So what was that item 9 and 10? In the second factors, it is related to spending time outdoors. The initial questions were like, spend time outdoor between 30 to 1 hour, 1 to 3 hours, more than 3 hours. So actually, maybe in Turkish culture, it is kind of confusing. So spending time 1 to 3 hours and 30 minutes to 1 hour, it may means that it is a good light exposure in the original one in English, but maybe in Turkish it means less or does not mean anything. Therefore, it disrupts the model. The next question was reliability. All 5 factors, we investigate the internal consistency of factors. Actually, the first one had the good reliability, but the 5th factors related to the daytime light exposure, it has very poor reliability. So that means using and evaluating the score of the factor 5th, we shouldn't rely on so much in that one in Turkey. Another validity was criterion validity. We also just collect the data if they are using glass and if that glass is with filter or not. And this is actually the first factor measuring. And it lets very significantly, accurately, all the time estimate the correct filter using. So that means this is the score and it measuring what it was. Also, another validity is light exposure heavily influenced by employment status and I compare different employment status and different factor scores, and there was a significant difference it measures, and it makes sense. Non-employed groups have, for example, less spent time outdoor, and they have less control over their nighttime or evening light exposure or screen use. And in the factor fives, in this time, they have more than the other groups. So that means, okay, we can collect questionnaire data and compare between groups, and it gives us significant, meaningful, real-world information. But then the other interesting question is the cultural effect, the language effect. So I returned to the previous study, the Malaysian one, and compare the scores to the Turkish one. And in most of the factors, actually, there are significant difference between Malaysia and Turkey. And that is good. That means that questionnaire captured environmental differences. But the interesting one is actually between Turkish living in Turkey and Turkish expatriates. And in some factors, there are significant difference in that as well. So that is a big environmental difference. So that is good as well. So that's still capturing environmental difference. But Malaysia, the Turkish expatriates always converge with the Turkish participant, not the Malaysian one. So that means there should be some cultural or ethnicity or language-related effects on that light exposure behavior. So even if they are living in another country, they still have very similar score to Turkish one. And the last analysis was that in the original questionnaire development, there were 48 items, then do reductions in the items and decide 23 items in the end. We translate all of them actually and ask the same question. If we do factor analysis and try to reduce, what will we end up? So is it the same 5 factors, or do we have another teams, another factors in Turkey? So we end up actually 6 factors in Turkey if we perform that analysis. So the first 5 factors, they were same, but we have additional 6 factors in Turkey. So the wearing blue light, exactly same. Spending time outdoors, we had some issues, and it is still there. Just removing some items, we are measuring the same things. Phone and smartwatch used, it is heavily used. Phone and computer and television used in the bed, not rely on smartwatch, but still measuring the same behavior. And the 5th factors, they have some technologies like down simulator. Instead of that, we had some interesting additions. It is like sunglasses or visors. It's like mostly preventing sunlight in bright daylight. So they were good additions. But still we are collecting the same team. So what is 6th factor? If you see the questions, they are actually controlling light in their sleep environment during light or how they wake up in the morning. So that is very consistent with our qualitative interviews. So that means definitely something going on in Turkey related to their sleep environment using light during sleep. Next, that is the story with Turkish Leba. We are still analyzing that data. We will soon publish that results. But overall, I can say that's a good questionnaire, collect lots of information. And when we translate it, even if we use the original 23 items, it is very successful collecting the very similar scores. Then the next question, we want to correlate light and sleep. So in literature, that is always based on laboratory studies, which are heavily controlled and very accurate, very informative, but not represent everyday life human. It's not representing our motivations, our stress, our tiredness in the everyday life, our priorities. Therefore, we should validate that findings in real world. So how we can collect sleep information in real world? We have sleep diaries, napping logs, momentary assessment of sleepiness throughout day, or validated questionnaire, mostly Pittsburgh Sleep Quality Index, chronotype questionnaires. For example, we have Pittsburgh Sleep Quality Index, and we are able to correlate this to light exposure data. There was not very strong correlation, actually. There are some very, very weak correlations, and they are in the expected direction from the literature. But it's not like representing the full story because they are very weak. So that means relying on fully subjective data in terms of both light and sleep is very limited. So then I started the protocol of collecting sleep, momentary assessment, objective sleep, subjective sleeps, and objective light exposure all together. And that gives us a very huge information of all kind of what we know, like KSS throughout days, like sleepiness, subjective sleepiness, continuous light, and reported sleep, measured sleep with objective devices. So starting with subjective sleep and recent light exposure. It is in the last 30-minute light exposure before the bedtimes, actually. If there is high light intensity, that makes our sleep onset latency longer and longer. So that is one of the first validation that evening light intensity is important for our sleep health. Also, the other correlation, this is all adjusted for time of day. That means independent of time of day, recent light make us more alert, less sleepy. And the effect size is slightly larger actually in the morning. So that means light can make us alert immediately. And in real world, actually, morning light to be alert, it is important. In the long term, this is like a weekly light exposure patterns and weekly averages of subjective sleeps. If we get a morning bright light, unfragmented and stable across the days, that is correlated with earlier sleep times, longer sleep duration, and less daytime sleep, less napping behavior. So that is also another validation that bright daytime, less nighttime light, stable light, which is what we know from suggestions and recommendations based on laboratory measurements, they are good for healthy sleep in real world as well. But this is just a subjectively reported sleep. So I want to collect an objective report, which includes sleep staging as well. But I want to use a wristband. So I used Fitbit Charge 5 in my study. They are not fully accurate to capture sleep staging, but I prefer to use wristband because this has enough memory, enough charge, waterproof, So I always prefer to like minimally invasive wearable device, so not change the real world behavior at all. So this is my prefer. And in this validation study, and this is through 30 nights, and correlate Fitbit wristband to EEG headband. And the Fitbit actually very good at measuring sleep start time, sleep end time. Very bad, like 40% error about sleep fragmentation. So we shouldn't use the number of wakes at night or duration wake at night. So this is very bad estimate. But the sleep stages, light sleep, REM sleep, and deep sleep, they are not so bad. And they were mostly precise, but deep sleep and REM sleep is mostly underestimated by Fitbit, and REM light sleep is overestimated. So in this protocol, this is 91 participants in the Manchester, UK, 550 nights. They wear Fitbit in one arm, light monitor in the other arm. And they report their subjective sleep as well, and collect 1 week of sleep and light monitoring for each participant. So that gives us both sleep data, sleep staging data, and light exposure metrics. So on the right-hand side, these are all the sleep variables I calculated, the same sleep wake time, sleep efficiency, sleep duration, but also REM sleep latency, REM deep light sleep percentage during the sleep duration, but also how deep sleep is distributed. It should be higher deep sleep in the initial phases of sleep and less deep sleep at the end of the sleep epoch. One question is that how objective and subjective sleep is correlated. And they are highly correlated in terms of sleep time, wake time, and sleep duration, to lesser extent to sleep efficiency. But then there is a concept of sleep misperception. So it can be actually the Fitbit is measuring the not correct way, or maybe it is collecting the objective data and people just have bias remembering their sleep. So mostly sleep duration and sleep efficiency, it is reported higher subjectively by participants, and that bias in sleep duration and sleep efficiency, if they have very poor sleep quality in terms of like less REM sleep, more light sleep, less deep sleep, they are more prone to making this error in their sleep misperception. So, and sleep misperception is associated with insomnia, schizophrenia, and depression. So that can be a good marker actually to measure. So this is still preliminary data, but we can continue to collect that data as well. So I don't know the reason for that. Maybe this is not the best method to measure this, but this is a first pilot data in this field. And also in this 90 participants, it is actually 2 cohorts of participants, and half of them used the SpectraWear, my device, and half of them used Condor Aklumus device. They both measure melanopic lux, used very similar sensor technologies. But before starting the experiment, we asked the question, are they comparable in the same data? If we use both devices, will it change the light exposure monitoring, light metrics? And for our data collection, for subset analysis, sensitivity analysis, actually they are not different than each other. So we are able to use both of them in study simultaneously. They correlated near perfectly in continuous monitoring through 5 days. And also we compare both of them to the calibrated spectroradiometric measurements. So they are very good at like perfectly measuring the same things above 10 lux, so 10 melanopic lux. So that is actually giving us some information about variable light monitors. So they are not yet perfectly sensitive to dim light. So maybe this is why all of my findings is related to morning light, because we are just able to measuring that one. Maybe we are not measuring the evening and nighttime light exposure perfectly. So this is a limitation, but there is still room for improvement in wearable technologies, sensor technologies, to collect more accurate and sensitive evening and nighttime light exposure. And what is the result of association between light exposure and objective sleep? It is actually very similar to what we have seen in the subjective sleep. So this is daily correlation, daily sleep, and daily light exposure. I just want to highlight one parameter here. This is a pre-sleep time, 3-hour mean light intensity. This is what I used. Just check the recommendation, daily recommendations. And it was correlated with the actually early sleep time, which is healthy, and longer sleep duration, which is healthy as well. So this is totally unexpected. And of course, this is not correct. They just mean that this variable, this metric, is not good. It is just confounded by early sleep phase, and maybe more daytime light. So we should end up more metrics for these recommendations. So there is recommendations, but what is the light metrics to measure using monitoring light devices? And this is the overall patterns of weekly averages of sleep and weekly light exposure patterns. It is like healthy light exposure, bright early morning light, dim nighttime light. These are correlated with the early sleep time and wake time. But one interesting association, which is unobserved before, is also stable light exposure pattern is correlated with a better deep sleep ratio distribution throughout the night. So if we have a good stable light exposure pattern, we have more deep sleep in the beginning of the sleep epoch and less deep sleep in the end. So this is the first real world proof that our light exposure pattern may affect our sleep architecture as well. So there are some other sleep, bright light timing exposure and deep sleep percentage correlations as well. So they are not statistically significant after adjustment of multiple testings, but they are definitely in the expected direction. So the effect size is lower. There are large inter-individual differences, which is actually the highest source of variance in this kind of study. But that means if you collect more and more data, then the results will be clear in that case. And we were able to understand that relationship fully. So was this light and deep sleep relationship reported in the literature before using polysomnographic devices? And the answer is yes. And actually it is in the expected direction. High intensity early daytime light exposure. So that is correlated with the increased deep sleep in the subsequent night. So this is very similar what we have seen. We have not observed anything related to evening light, but that is also this deep sleep distribution, and that is correlated with the evening light exposure. And importantly, it was the short wavelength dependent. So we need to measure accurately the light exposure in real world. We should collect more melanopic lux information from real world. more data, more participants, more cultural context, and then we were able to answer all this kind of associations. Thanks for listening to me, and thanks for my funders and my research group in Turkey now.